polar, hydrogen bonding, adhesion, cohesion. Well, what is something that you encounter every day, but without it, we'd not be here on Earth? We often take it for granted. Do you have any ideas? If you're thinking air, you're starting to think along the right track, but you're not quite there yet. Let me give you another hint. The substance makes up about 60% of the human body, and no, it's not air. Any ideas yet? Well, if you were in the middle of the ocean, and you'd be floating in billions upon billions of molecules of it. What do you think it is? That's right, it's water. And today we're going to be talking about water and all its amazingness. Well, what is water anyway? Water is a substance that goes by lots of different names, like dihydrogen monoxide, properly speaking, or the name of the universal solvent, which is a nickname, or H2O, which is a chemical formula. We'll be focusing on this H2O part of what water is because that's what it goes by. What is H2O? Well, let's look at it here. It has two parts. There are the H2 and the O parts. The H2 stands for two hydrogen molecules. Hydrogen is an atom on the periodic table, and there are two of them. Two hydrogen molecules plus one oxygen molecule. Every single molecule of water is made up of two hydrogen and one oxygen. And the reason we use a subscript here in our H2O, let me highlight it here. The reason we use this subscript is to show us that we have two molecules of hydrogen, two atoms of hydrogen, sorry, and we have no subscript here for the oxygen because there's already one oxygen there. So if we have no subscript, it means there's one oxygen. If we have got two, it reminds us there's two hydrogen atoms there. A single molecule of oxygen looks a lot like this. Let me get the pointer here. We get our big red oxygen atom, our tiny hydrogen atom, and another tiny hydrogen atom. Now, if you look at it, you may be noticing it looks kind of like an inchworm. Crawling along. His little inchwormy tail and a little smile on his face. Or, if you're using your imagination, it looks kind of like Mickey Mouse ears upside down. But it's this way because it's got a special shape. This special shape happens because of the way that the atoms, the hydrogen atoms, and the oxygen atom bond together. Remember, the hydrogen atoms are bonded to the oxygen atoms because of covalent bonds, which means they share electrons. There's one electron from each hydrogen atom, and there is one electron from each oxygen atom that are shared. I'm drawing these green dots here to represent the valence electrons on the oxygen, and I'm drawing these yellow dots to represent the valence electrons on the hydrogen molecules. And that is what an oxygen molecule looks like because those are bonded together covalently. Notice there's sharing of these electrons for this hydrogen atom with this oxygen atom and this hydrogen atom with this oxygen atom. They are sharing those electrons covalently. Well, water is a very special molecule because of the way it shares its electrons. You see, when the electrons are shared, here's our hydrogen again. Let me remind you, this is our oxygen. When those electrons are shared, those electrons spend more time over by the oxygen because the oxygen is kind of like a big atomic bully in relationship to the hydrogen. Those electrons spend more time with the oxygen, which means there's a very slight negative charge. Because remember, electrons are negative. Electrons are negatively charged. And that causes there to be a very slight, and this is the symbol we use. That's a lowercase delta from the Greek language. And it is a very slight negative charge on the oxygen atom. And because of that, there is a very slight positive charge. Remember, that's the slight symbol, very small, positive charge on the hydrogen atoms. And notice there's a negative charge over here and a positive charge over here. And when that happens, there's also a positive charge over here, by the way, because there's another positively charged hydrogen. There's different sides of this oxygen atom. When there's different sides, you end up having what's called a polar molecule. Polar simply means it's got two sides. Kind of like a magnet. You remember what magnets look like? They've got two sides. There's a south side and a north side. And if you know anything about a magnet, the south and the north side will connect. The south side here will connect to the north side. They're attracted to one another. Well, in water molecules, it's similar to that. You see, in water, you can have lots of water molecules, and the different sides are attracted to one another in this process known as hydrogen bonding, because there's a slight negative charge over here and a slight positive charge over here, a slight negative charge on this oxygen atom and a slight positive charge on this hydrogen atom of this water molecule. Again, slightly negative, slightly positive. And what happens is the positives are attracted to the negative charges. And that causes what we call hydrogen bonding, which is this attraction between, a very slight attraction between one molecule of water to another molecule of water. And this is how hydrogen bonding works. You can bring out tons and tons of different water molecules, and in every water molecule situation, it's always going to have bonding between positive sides and negative sides in very slight ways. That's hydrogen bonding, and that creates a kind of force between the water molecules. Now, what happens with those polar molecules which have hydrogen bonding happening is there is something called cohesion. Let me write that out for you. Cohesion. Cohesion happens when water sticks to itself. Notice this co in the word cohesion. It's like cooperate. You cooperate with somebody, you're working together with them. Water molecule sticks to itself with cohesion. And there's also another concept which you need to understand, which is called adhesion. That adhesion part talks about sticking to something. Well, this water sticks to other things. Usually those things are things that are polar, and that is adhesion. You should know the difference between cohesion and adhesion, and they're very special properties of water, which you should understand. Now, this happens because, I'm going to clear the screen here, show you again this water molecule. And if we have other water molecules, water can stick to itself, and you should be remembering what it's called. This process, this kind of bonding that happens between different water molecules, between the positive and negative sides of water, that's hydrogen bonding, causing the cohesion of water, and that holds water together. And then there's adhesion, which is water being attracted to other things. You should be able to identify what's going on in this next picture here. What I'd like you to do is I'd like you to take a moment and look at this picture, identify what you're seeing, and think about what you're thinking or what you're seeing. Do you have it in your mind? You should be able to describe what you know is happening in this picture based upon the properties of water we just talked about. I'll give you a moment. If you pause your video at this point and write it out, it's going to help you a lot more than if you just continue listening. So take a moment and pause the video and figure out what's going on. Welcome back. What's going on in this video or in this image is you see the property of cohesion happening here and here. The water is sticking to itself to form a drop of water. Also, you're seeing adhesion here. The water is sticking to the metal. Why are adhesion and cohesion happening? Well, the cohesion is happening because of hydrogen bonding. And the hydrogen bonding is happening because cohesion happens because of hydrogen bonding causes cohesion. And the hydrogen bonding happens because water has two sides. It's polar, a positive side and a negative side. So the polarity of water causes the hydrogen bonding to happen, which causes cohesion to happen. Or the polarity of water causes hydrogen bonding to happen, which also causes adhesion to happen. And that, my friends, is what water is, and all of the properties of water in all of their amazingness. This is Mr. Willems. Thank you for watching. Don't do anything my grandma wouldn't do, and make a positive difference in somebody's life today.